We know that if we have a constant number over plus or minus infinity, we will get 0. Again, it is because a fixed number is divided to infinite many pieces, so each piece has to be very, very tiny. But you can just do the algebra and get that if a number over plus minus infinity is 0, then a number over 0 is plus minus infinity. 0 and plus minus infinity are reciprocals of each other. We can see the pattern. I'm going now to take 1 and to divide 1 to a smaller and smaller number each time. And you can see that we get actually a larger number. You can realize what will happen if I will divide 1 by a very, 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 very tiny number. I'm going to get a huge number. In general, if you have a fixed number and you divide by a very, very small number, and I don't care if this is a positive number or a negative number, then I get, in absolute value, a huge number, which means plus or minus infinity. Example, let's evaluate the limit of 1 over x to the power of 2 when x approaches 0. When x approaches 0, x is almost 0. And that's why we get that this is actually of the form of 1 over 0. So I know because it is 1 over 0, we should get plus minus infinity. We are now going to write 0 plus for a very small positive number, which is almost 0, and we will write 0 minus for a very small negative number, which is almost 0. Because 1 over x to the power of 2 is undefined at x equals 0, we evaluate the right and the left-sided limits. The right limit at 0 is 1 over 0 plus to the power of 2, which means that this is 1 over a very tiny number but positive 1, so we get infinity. You can again think about the reciprocal of the 0 to be infinity, so when you have a positive 0, you get plus infinity. At 0 minus, we get that, but when we square the 0 minus, we get a 0 plus, and we get infinity again. You can see that both limits are infinity, and we can conclude that the limit of 1 over x to the power of 2 when x approaches 0 is infinity. Example, evaluate the limit of negative 3 over x to the power of 2 when x approaches 0. Again, you cannot just substitute 0, so we must evaluate the right and the left-sided limits. From the right side of 0, we get negative 3 over 0 plus to the power of 2. So it is negative infinity because we have negative from the 3. From the other side, from the left side, it's this one, but we get, again, negative infinity because when you square the 0 minus, you get a 0 plus. And we conclude that the limit of negative 3 over x to the power of 2 when x approaches 0 is negative infinity. Example, evaluate the limit of x plus 1 over x minus 3 when x approaches 3 from the right, and then we will do the limit of the same function when x approaches 3 from the left. Please realize that the domain of this function is all real numbers except x equals 3, So it is impossible to substitute x equals 3. Also note that if you substitute x equals 3, you get 4 over 0. It's not 0 over 0, so we cannot expect to have cancellations here. Let's start with the limit when x approaches 3 from the right. We have to do some mental work here. You substitute 3 when you can. I don't have any restriction to substitute 3 for the x in the numerator, but I cannot do so in the denominator because I will get 0. But 3 plus minus 3 is not exactly 0. It's almost 0. We know that it is very tiny. The question is what kind of a tiny? We have to do the following mental work. 3 plus is a little bit more than 3. It implies that 3 plus minus 3 is greater than 0. It means that it is 0 plus, because we know that it's very tiny. We know that this is 0. The question is this is 0 plus or 0 minus? In this case, we get 0 plus. And we get 4 over very, very tiny positive number, so it is infinity. Now let's take the other limit. We have to do exactly the same mental work. 3 minus is a little bit less than 3. And that's why, if you take from less than 3, you take away 3, you get already to the territory at which it's negative. And that's why it is 0 minus. We get 4 over 0 minus, which means very, very, very tiny number, but negative. 4 is positive, so we have positive over negative, so we know this is negative. But also we know that it plus or minus infinity, and because it is negative, it must be negative infinity. By the way, if you look at those two limits, you can conclude immediately that the limit when x approaches 3 does not exist. Let's now evaluate the limit of x over 2 minus x when x approaches 2. Again, you cannot establish it 2, so we have to do the 1, 2, 3 theorem. We will start by the limit when x approaches 2 from the right. We are going to substitute 2 when possible and 2 plus when it's not possible to just write 2. Let's do the mental work. 2 is less than 2 plus. So 2 minus 2 plus has to be negative because you take away more than 2. It means that 2 minus 2 plus is 0 negative. It's a very, very tiny number, but negative. So the limit is negative infinity. Now we are going to take the other sided limit, the limit when x approaches to 2 from the left. We have to repeat and do the same thing here. 2 is more than 2 minus. So if you take away less than 2 from 2, you get something positive. Very tiny, but positive. So we get 0 plus. So the limit is 2 over 0 plus, which is plus infinity. Now we have to observe those two limits. Definitely they are not the same. We can conclude that the limit at x equals 2 itself does not exist.